Good evening, Doug Simonian over at New York Metro Weather with your latest video discussion. We're going to be structuring this video into two general topics. The first half, or maybe about 2/3 of the video, depending on how long I talk, will be about the couple of snow threats over the next week or so across the east. And then the latter half, or maybe the latter third of the video, will be more so focused on the Arctic cold and what exactly is causing it, as well as a peek at some potential low numbers that could be realized in New York City. So, take a look at the European model, generally just to illustrate the point about the storm threats. We can see that right now we have a kind of a pseudo blocking feature in southeast Canada that has split the tropospheric polar vortex into two elongated pieces, and the elongated piece extending from southeast of Greenland all the way down into southern Quebec and northern New England, that has provided a lot of resistance in that a storm has little room to amplify in this kind of pattern when the flow is very compressed and flat. Of course, with this tropospheric polar vortex piece overhead, you get very cold weather, and of course we'll talk about that later. But as far as a storm threat, that has been mitigated, especially also considering the other side of the splitting piece has worked in tandem with a somewhat expanded upper level low in the Pacific to flatten this ridge in the Pacific, leading to less storm amplification as well. So as you scroll through time, we can see that this one feature, the shortwave feature that dives south of the tropospheric polar vortex, is kind of getting shredded into pieces. It doesn't really become its own entity to amplify or really develop its own low pressure system. And we even see a weak low pressure system get shunted way out to sea in this time frame when the computer models were originally forecasting a big snowstorm. That will, of course, no longer happen. But what does intrigue us slightly is the energy diving on the back side of this disturbance, more so directly associated with the larger piece of the tropospheric polar vortex. We see that the flow in the Pacific, there's a little bit of a ridge amplification. It's still pretty flat, but just enough when combined with the cross-polar flow in northern Canada from due north to south to send an own entity of powerful Arctic shortwave due southward into the northern plains and then into the Midwest and into the Ohio Valley as well. And downstream of this shortwave in the Ohio Valley on Saturday afternoon, combined with a very cold Arctic air, you can get just enough lift to produce some very light, fluffy snow on Saturday across some of the mid-Atlantic and into the Northeast. Although the disturbance is pretty potent, it still doesn't really become its own entity thanks to the leftover elongated piece from the tropospheric polar vortex still lingering. If this were to separate and become its own piece, let's say we're able to kind of cut this vorticity in half, so to speak, where this shortwave has its own positive advection, as opposed to its vorticity running into other vorticity, and thus you're not getting a net change in vorticity. It's the change in vorticity that really leads to lift for precipitation, not vorticity itself. That's why it's so important for this to become its own entity if you want a more sizable snow event, which is still somewhat possible, though probably a little bit less likely now. But either way, the disturbance is still potent enough and generates a strong enough area of vorticity to where you can still net some change in vorticity to generate lift for precipitation. And of course, as I said before, in the strong Arctic air mass, it won't take a lot of precipitation to produce a couple of inches of snow, which is still certainly possible on Saturday. And then there may be a little bit of coastal enhancement as well, maybe for some locally higher amounts in some spots. Though again, if this becomes even less of its own entity, the amounts could even be less, about a decim to an inch. We'll look at the surface response on the European model. Again, this is from the WSI Model Lab, these plots. So we see the Arctic low pressure coming down that tropospheric polar vortex piece, bringing some light snow in the Ohio Valley on Friday night, Saturday morning, and then somewhat leading to a little bit of an Atlantic low pressure development to enhance the moisture that initially gets dried up by the Appalachian Mountains. So some light, very light snow across the area on Saturday morning, and then a little bit of a lighter to briefly moderate burst of snow Saturday afternoon on the European model. This is probably, about an inch, maybe a couple inches, and some locally higher amounts, about a couple inches if this is right. There is still room for this to be a little bit on the snowier side. The UK model, for example, had this low pressure being a little bit more consolidated and the shortwave being a little bit more of its own entity. So the precipitation in the Ohio Valley blossomed a lot. We even see there is a little bit of height rises ahead of this shortwave as well. So when you get the height rises, you actually get a little bit of warm air advection. So when you combine the warm air advection with the positive vorticity advection, you can get some lift for precipitation. So the UK model is actually more expansive and heavier with this precipitation. And actually, when you account for the Arctic air mass, produced several inches of snow, which is probably on the upper end of possibilities. But that possibility still cannot be ruled out when you account for the potency of the Arctic shortwave and the cold air mass that we'll be having. After that, the storm moves out to sea, and then behind it we get a reinforcement of the cold air mass. So it actually gets even colder across a good part of the eastern U.S. Another shortwave gets kind of sheared out and moves out to sea, and a few days after that. But then as we head towards January 2nd, we'll have to watch for another storm system entering the Pacific and into the U.S. and diving down due north to south in a different way than what has been shown for previous storms that did not work out. What's really interesting is how the event can get started. This is the Twitter feed of Tomer Berg. I think he provides a lot of very interesting model plots, so I would suggest checking out some of his work. But he tweeted out that there's a bombogenesis event, which is just a rapid low pressure development, in the Western Pacific near Russia. And what that does is it leads to what we call a cyclonic wave break. So that means you get a storm system that's so strong that it actually changes the ridge and trough wave pattern across the areas downstream of the storm. So we get a very strong storm in the Western Pacific, and what that does is it pumps out a lot of latent heat out ahead of it, not just so that the ridge moves ahead of it, but the ridge breaks and causes a large blocking feature in the Western Pacific. And that large blocking feature leads to an even stronger negative anomaly to be stagnant downstream. And that negative anomaly downstream near the Aleutians, combined with another small negative anomaly downstream of the wave break as well, will both work in tandem to pump up a very large ridge in the Northeast Pacific and into western half of North America. And when you get a large spiking of the ridge like that, you have to pay attention for lots of amplification on the east side of that ridge, and thus a potential storm system in the east somewhere in the January 3rd to 5th period. So we'll take a look at how that transpires on the European model, verbatim anyway. We even see that the wave breaking event actually occurs pretty soon. So although the storm was relatively far out in the future, we already see the ridging amplifying as soon as Saturday downstream of this vortex feature near the Aleutians, and another upper level low further south in the Pacific that both work in tandem to pump up this ridge. And that ridge actually gets pumped up even further as we scroll through time into the new year. And as a result, we get multiple pieces of energy diving down this ridge, one in British Columbia and into the Intermountain Rockies that slowly dive southward. And then the ridge spike gets re-enhanced by this upper level low, combining with the upper level low kind of shifting in orientation to where we get another ridge spike near British Columbia, sending down a second potent shortwave down Alaska and further south. And what happens on the European model is that these two pieces of energy would eventually phase together and form a coastal snowstorm. And when that's combined with plenty of cold air situated in the northeast thanks to the departing elongated tropospheric polar vortex pieces, the ingredients in the macro sense are certainly there for a snowstorm in that period. Of course, there are some flies in the ointment that could lead to some de-amplification. Of course, there's some lingering energy that prevents the pattern from truly getting consolidated on this model run verbatim. But still, look at this beautiful north to south flow across some large portion of Canada. That means the shortwave is going to rapidly dive southward. And then, of course, in the southeast, the system actually is forced to slow down because the gradient is a little less. So when this original shortwave is forced to slow down, this one has to accelerate thanks to this very tight gradient and stark due north to south flow. It can catch up and phase. And then we actually get, on this run, the phase kind of just misses. It's only a partial phase. But you see the potential here as this becomes a full latitude trough in the eastern half of the U.S. thanks to the big ridging event in the Pacific. So when you get this big full latitude trough attempting to phase with other leftover energy in the Pacific that dives into the southeast U.S. and taps into the Gulf, you get a lot of moisture, latent heat release, height rises, and amplification as well. So certainly that will have to be a time period to be watched. We even see the trough goes negatively tilted as well, though on this run verbatim, the flow is a little broad thanks to the leftover energy in southeast Canada preventing the wavelengths from tightening, and the lead energy didn't quite phase into the trough cleanly, so that led the baroclinic zone to be a little further southeast, but still the potential is clearly there on the European model, and it is supported by ensemble guidance as well. Some of the ensembles are showing some really impressive solutions. So we can see that at the surface, this very strong north to south flow and strong Arctic high pressure again diving due southward, and we see the energy in the southeast that is kind of getting merged in and phased with the full latitude trough. And as a result, we get a coastal low pressure system that developed pretty quickly. But because of the lack of consolidation, the storm gives a light to moderate snow event verbatim. Of course, we really don't want to take models verbatim at this range, but it's just good to show an illustration based on them. So the storm climbs the coast on January 3rd into January 4th, and then strengthens thanks to the full phase and negative tilt taking place, bringing a lot of heavy snow to New England. So this will certainly be something to watch. Also notice that there was a lot of trailing energy too, which shows that there are some timing discrepancies too. Some of the ensemble members are actually a little bit slower with the evolution. So the European shows the storm January 3rd to 4th, but some other ensembles are more like January 4th to 5th. So there's a lot of details that still need to be ironed out with the storm threat so far away. With the true negative tilt to the trough not taking place till January 4th into January 5th. That may be where it makes a little bit more sense for a bomb to take place. But again, if this southern energy were to slow down a bit, or maybe even disappear entirely and let the trough, the northern stream trough, do all the work, then you could get a big coastal storm in the earlier time frame as well, January 3rd to January 4th. But again, there are flies in the ointment. There isn't really a whole lot of help in the Atlantic as far as a negative NAO is concerned to really buckle the flow a lot. The buckling is pretty much all due to the Pacific. I mean, we've gotten plenty of snowstorms that way, but it decreases the room for error when you don't have a lot of high latitude blocking in the Pacific. But either way, that is a storm that we will be watching and that we will be talking about in length over the next several days. Now let's talk a little bit more about the cold that is being shown on these forecast models. We'll just quickly scroll through the European surface again, and we'll see this 1040 millibar high pressure, and just in general, this very expansive nature to this high pressure in southern Canada that leads to so much cold air being dislodged into the U.S. And that really continues to be the theme over the next several days, and each cold shot gets reinforced by a departing storm system near Newfoundland, where you get cyclonic flow on the backside of it that allows the cold air to seep southward with more reinforced areas of very strong Arctic high pressure. And actually the high pressure to New Year's Eve is even stronger. 1052 millibars or even stronger on the European ensembles. And the high pressure, it sprawls. It's very expansive. It's not just isolated to one area. It covers a large chunk of the entire U.S. So you're able to get many areas of cold air advection from a truly Arctic source into a large portion of the U.S. And as far as where the cold can get maximized in the Northeast, we're looking at somewhere between New Year's Eve night and January 2nd, when you see more of the due northerly flow in the mid and low levels. If we look at the European model aloft, we have these little lobes of energy, right, that kind of allow more of a somewhat due north to south flow across like Hudson's Bay. So you get the air mass does not get modified by the Great Lakes. It just goes straight down from Canada into New England. That's how you get your coldest nights, and that's when some of the New York City suburbs could actually get below zero the night of January 1st into January 2nd. So something certainly to watch. And then with the coastal snowstorm potential on January 3rd to 4th or so, you get another shot of reinforced cold air behind it as well, with more areas of high pressure developing. The Arctic high pressure is not as strong this time around, but you're still getting a solid area of high pressure that reinforces one more cold shot into the east January 5th to 7th before we do think we'll start to see some moderation. We can even look at the temperature anomalies on the European ensembles from today. They're obviously very impressive across much of the U.S. We see the big cold shot for tonight and tomorrow and into the night of the 29th as well into the Northeast. And then that shot of cold air gets strongly reinforced by that second strong area of Arctic high pressure. So this area, this cold shot could actually be even more impressive than the previous one. And this cold will eventually bleed east as the Arctic high pressure greatly expands. So look at these impressive anomalies across the entire U.S. To start the new year. It's going to be very cold at the ball on New Year's Eve. That is safe to say. And the cold continues to be impressive. They'll move east with time, as there will be some, as of course that ridge spike happens along the west. And there are some signs of moderation taking place, but not before another shot of cold air gets reinforced behind that potential storm system January 3rd to 4th, leading to another shot of cold air in the east before things moderate a bit, and then we might go into a more traditional La Nina pattern of a trough in the west and a ridge in the east, though some leftover areas of high pressure downstream of Pacific ridging could still lead to some cool air in parts of the east as well. We can look at why these areas of high pressure are so strong on the GFS ensembles. One of my favorite things to talk about in meteorology is the jets, in particular jet streaks. When you are in the right side of where the jet streak is beginning, a jet streak is a maximum in the jet stream, you generally get more areas of lift for low pressure, because that's it where you get areas of upper level divergence, where winds at the very top of the atmosphere spread out, and when the winds spread out there, in order to create, in order to balance the pressure that you're losing from the air spreading out, you need lift. Kind of like when you're opening a soda can and the air gets released, right? Right? There's kind of like an upward lifting of that air in the soda can. So when that air is getting spread out and diverging, you get a lot of lift underneath it, and that's where you get low pressure, right? But then the opposite occurs on the left side of where the jet streak begins. So we see that right now, this is a strong jet streak across the central U.S., and on the right side of where it begins, we have a low pressure, and on some quote-unquote the left side of where it begins, the left entrance region, you get a strong high pressure. And there's another strong area of high pressure near Greenland as well that will be diving down into the U.S. later in the week. But of course, we see this high pressure. Look, it's classically located just to the quote-unquote left, the left quadrant of where that jet streak starts. So that high pressure is 1047 millibars and very expansive. And of course, there's a strong cold air source thanks to the piece of the tropospheric polar vortex being dislodged into southern Canada. And then we see another jet streak forming in the Pacific, and also a jet streak forming, a weaker one near the Arctic as well. But what happens here, look at this jet streak. The quote-unquote left side of where it starts is another area of high pressure, right? And also the upper level winds here are converging. When you have upper level convergence, that leads to air sinking beneath it, and thus more high pressure. And that's why we have another strong area of Arctic high pressure. This one even stronger than the previous one. 1050 millibars, 1051 millibars on an ensemble mean. It's a very impressive signal. This is for January 29th and the 30th, and that's why the cold shot New Year's Eve into New Year's Day will be actually even more impressive than the one we already have. And it's also helped by cross-polar flow. Look at this flow, due north to south from the poles into the U.S. So it was a classic recipe for a big cold. And this cold was very well signaled well in advance. So anyone who doubted this cold due to snarky remarks is clearly wrong. So this cold is very impressive and it's here to stay for a little while. And this high pressure, it's still 1051 millibars even into January 1st, again on the left side of where that jet streak begins. And then again, there is another area of high pressure, again on the left side of where this jet streak begins, behind the potential storm system that forms, leading to another shot of cold air before the potential January thaw occurs, maybe later in the first week to the second week of January. Here's some numbers on the European ensemble mean for New York City. We see that on, well, of course, tomorrow, highs will struggle to get out of the teens. So New York City suburbs will most likely not get out of the teens tomorrow. Lows in the city in the low teens, so the suburbs, upper single digits. But then New Year's Day, the mean shows only a high of 18 and a low of 10. And the spread, this is a box and whisker plot. So the gray box is 25 to 75% confidence interval. So like the first quartile, the third quartile, if you're a math nerd like me. And then the blue bars are 5 to 95%. So it's not a true box and whisker. It doesn't include all the plots, but it includes most of the ensemble data. And then we see that on the New Year's Day, the mean is a high of 16 and a low of 4 in the city. That is extremely impressive. And if you look at the box and whisker for the low, the spread is so tight. The warmest, the 95% warmest outlier, so to speak, is only 7 degrees, and the 5% on the low side is 1. So pretty much every European ensemble member has a low between 1 and 7 on New Year's Day, with most of the clusters being somewhere between 3 and 5 degrees. That is very impressive for New York City this time of year. And of course that means the suburbs could get below 0. And then we get the same thing occurring January 2nd. The mean shows a low of 5. And actually the spread's a little larger. I think this is because it may depend on if there's more snow cover. You can get the low temperature a little bit lower. Notice the spread is larger, so there's actually a few members below 0 in New York City. We don't think it'll go below 0 in New York City, but it's just to show that there is a little bit more room for the cold to maximize on the morning of the 2nd because the spread's a little larger. So either way, there's a couple of days where there could be some below 0 mornings in some of the New York City suburbs. And even still, for a long period of time, high temperatures in the upper teens to low 20s, maybe some mid-upper 20s if there's a storm system happening, and then finally we warm up a little bit on the mean in the second week of January, but still really not that warm. Alright, so I hope you enjoyed this video. I know it's a little bit long, but there are always interesting things to talk about regarding the weather. So we hope you enjoyed this video, and have a great night, and we will talk to you guys soon. Take care.